Welcome, everyone. I'm Shah, and this is the Day Entrepreneurs Podcast. Super excited today because I'm talking to Nico, who is, I don't even know how to introduce him because he's up to so many different things. He's a AI practitioner. He's managing director of an AI shop called Eisbach in Germany. He's the host of the How AI is Built podcast. He is a product entrepreneur building AI products and a fan of the Sunday Running Club. Did I miss anything, Nico?
Yeah, I think you covered most of it.
Well, thanks so much for joining me today. I always learn a lot from our conversations because you're such a avid builder and practitioner. So you always have a pulse on what is happening in the world of AI from an engineering perspective, but also since you're constantly working with clients, you have a really good perspective on the value generation that AI is capable of. So yeah, thanks for coming on and sharing your insights with everyone.
Now I have to live up to the expectations.
I really hyped it up, so really high bar. So I guess maybe just for people who aren't aware of what you're up to and don't follow you on socials and stuff, just give a brief background to how you got into AI, what you're up to these days, things like that.
So I got into AI during university, and I got my start from the get-go in LLMs. So in 2019, a buddy of mine actually introduced me to the BERT models and the early GPT family which came out, and I just got caught immediately and started building some stuff, started training some AIs, and then started freelancing actually in it, where I mostly have done in the beginning fine-tuning models for certain specific use cases, and over time evolved more into more complex stuff, complete applications, early trials at building agents, which is something we will talk about today. And then at some point decided to start our own company, which was an agency in the end, where we are now doing complete implementations of larger data and AI systems.
That's awesome. And I didn't know that you got started with BERT and GPT, but I feel like that is a perfect story because that was really the beginning of what people now might call software 3.0, which is this age of, instead of asking yourself, okay, how can I get some data together so I can train a model from scratch? The starting question might be, oh, what model can I repurpose or take off the shelf, fine tune it, or build some software around it to solve my problem? And that's exactly what you were doing when you first got into AI. And so now that has kind of evolved to now people talking about AI agents, and even you building these early AI agent systems. We hear this term a lot, like AI agents or agentic systems, but what is an AI agent? How do you think about that? How do you define that for yourself?
I think an agent has become more of a catch-all term. It covers a lot of ground, and I would say it's agency. It's a spectrum.
Mm-hmm.
So you can use it in a lot of different ways. I would say for me, pure agents is the reinforcement learning perspective. That's a true agent for me, but that's not what is really being built in most cases, because
Yeah.
it's way too complex. So basically an agent in reinforcement learning, you have an environment, the agent observes the state, which is basically all the information you can give it about the environment he is in. Then he makes a decision of what to do next, performs the action, he gets a reward signal usually back, and basically repeats the cycle. And over time, he's learning optimal behaviors, and the behavior is basically just a probability distribution, which is dependent on the state, the information I have about my environment, which basically bias the distribution over the different actions an agent could take. I think this would be the truest form of agent, but is not how it's used today.
Right.
And today it's everything from an LLM with a few tools, which it can call freely, is an agent. I'm not sure whether I like it that way, because I think the definition has lost a little bit of its meaning in technical terms. It has become more of a marketing term nowadays, I think, because when I say agents, any techie, you couldn't really say, what do I mean by that and how would I implement it?
Kind of like how Gen AI, last year, I feel Gen AI is used less now, and maybe now it's more AI agents, but there's definitely a lot of energy in the public consciousness about AI, and it's just being manifested through these different buzzwords, maybe.
I think it's interesting how we can stack, how Gen AI is able to stack hype cycles on top of each other.
I guess taking a step back, people hear about AI agents, and then there's this vision of the future of what that could mean and what the impact they could have. At this point, like, why should we care about AI agents? And is it just hype, or is there like some real practical value that we can extract today?
The agents, how it's implemented in a lot of framework. So for example, Crew AI, where you actually have also free planning, where the agent can plan what he wants to do and then basically distributes the work to different sub agents or does function calls and then basically reacts again, like the React framework reacts on the state and decides on a new action, adjusts the plan. I think something like that will have real issues when I take it to production or
Right.
when I want to deploy it, especially in a B2B context. And this is also like the key metric, like how critical is the output or how sensitive is the end user when something wrong happens.
Right.
And in a B2B setting, it's very critical because if your agent has a task completion rate of 30%, people won't really use your tool because there are
Right.
better options out there using plain software or using a workflow, which is what we are mostly doing. In a B2C setting, it depends on what the agent is doing and how costly it could become. I think like Stripe brought out their agent framework for payments. I think like nowadays with like the hallucinations and stuff like that, but also the task completion rate I'm seeing from like free planning agents, I wouldn't trust it with like my wallet or my credit card.
So I guess, like, are there any situations that you feel like AI agents make sense right now, or you still think it's too early?
For something that has to be creative or where I want a little bit
Okay.
of variation or a lot of
Yeah.
variation in it. There they can bring a lot of value, but where it's basically more about discovery and not like doing something the same way for
Right.
like thousands of
Right.
different inputs.
Right. Okay. So if you need like something that is exact, like basically an assembly line, it's like, I need to mass produce this thing and it has to be this way within these requirements. Building these multi agent LLM systems, it might just
Yeah.
be too unpredictable to get a reliable output. But if it's more like a creative task or maybe researchers trying to explore new scientific ideas where you're trying to,
Yeah.
it doesn't matter if it's wrong like 9 times, but that one time that it gives you an interesting insight, it's kind of worth all the exploration.
Yeah. And I think like for this, we will see like more and more interesting stuff happening
Yeah.
as inference becomes cheaper.
Hmm.
And because
Right.
I could just like, even if the success rate is like 0.1%,
Right.
if it's like a really like the payoff is immense,
Right.
which it should be for a lot of research, especially fundamental research, I
Hmm.
could just send off thousands of agents doing like different strands of research and just review the outputs. And
Yeah.
I might have like one interesting idea, which I then actually want to pursue.
It reminds me of when I was in grad school. I had a friend, we'd always be at the bar on a Friday afternoon or something like that. And he would always say, yeah, my code is running, so I'm technically doing research right now. So that's what your vision of AI agents reminded me of. You just have these agents going off, like exploring different hypotheses or, doing some kind of exploration while you're at the bar having a beer or something, and you're just telling people how you're doing research right now. What does it take to like build one of these systems? And I guess you said it's on a spectrum. Maybe let's just start with like a pretty basic one where you just have an LLM and you're trying to get it to reliably use tools, or to use tools effectively, or just something basic like that. Like, what does it
Yeah.
take to make a system like that?
So when it comes to tool calling, you have two different ways in which an AI can trigger a tool. In most ways, it's basically through special tokens, which you train the LLM to use. So basically, when you're doing instruction fine-tuning, so you have input-output pairs. You also include in the output pairs when it should do a tool call. And then the tool call is basically not just like which tool I'm using, but usually also the inputs. So it can be like you're running a retrieval, but in a retrieval, you just don't want to feed in like the random input you had before, but maybe like specific parts of the tags, maybe some additional categories or metadata to filter on. And then basically it's generating the tool call, like the token to trigger it, the input data, and then basically the tool call is done. This is what I've seen a lot. I'm not the biggest fan of it because it's like it's harder to control
Right.
and you have to fine-tune the LLM to do another behavior. So you need a lot of training data. And if you're training an LLM for a specific task or for your domain, like adding this additional behavior on
Right.
top can lead to a little bit of conflicts in behavior. So what I prefer is to have like a secondary model, which often like a small classifier,
Yeah.
running on all the different outputs and just basically saying yes or no whether a certain tool has to be triggered, or when you have many tools, you basically have like a multi-class classification.
So instead of like baking in this tool use functionality capability into the LLM, into this like singular integrated system, you just like modularize it. So you just kind of like split
Yeah.
it off. And you have like a classifier watching the input, watching the responses, and making a very simple decision of would it be helpful to do retrieval here? Would it be
Yeah.
helpful to make this API call here or something like
Yeah.
that?
And then basically when you classify it, so I need to run a retrieval, you would basically have another smaller LLM or the same LLM basically generate the function signature, like the
Yeah.
function call, like the
Oh, I
inputs,
see.
whatever
Okay.
I need. It adds a
Um,
few steps, but I think like modularizing it
yep.
allows you to actually optimize each component
Right.
on its own, which in my opinion often leads to a better system overall, as when I hope that I can bake in more and more stuff
Yeah.
in one single model.
And then it kind of helps avoid because you were talking about multi-agent systems earlier, and I imagine like a lot of people's like first instinct might be, especially people that are coming from their entry point to AI is like ChatGPT and making API calls to large language models. So their first instinct might be like every component is a different LLM, is a different API call to like OpenAI or Claude or something like that. But you're easily going to run into issues in these multi-agent systems where like the errors will propagate and they'll kind of like compound on each other exponentially.
Yeah.
But like what you're talking about is you don't have LLMs, like multiple LLMs. Like maybe you just have one, and then you have these like small lightweight text classifiers, which are much more predictable, that are kind of augmenting the LLM's behavior and output.
Yeah. And these could even start as small models or
Yeah.
like a GPT-4 or mini call, which is very fast when you don't have any training data yet.
Right.
And this allows you to basically bootstrap training data so you
Mm.
can train a classifier over time.
We've talked about a few things. So we talked about LLMs. We talked about these like smaller models, like maybe a small language model or a text classifier. What are some other essential elements or essential components that you might want to include in even just like a basic agentic AI system?
So my favorite one is actually building workflows. I treat it more as a graph of steps, and we had a few implementations. I had the first one as a freelancer where we built something in, it was I think 2021, so fairly early, where the accuracy of the response it wasn't really good. So we really had to decompose the complete task, and we ended up with a really like high task completion rate.
Mhm.
And the same stuff we are still doing now. Like the models have gotten better, but when you chain a lot of calls or you have to complete something fairly complex, you're still often better off breaking the task down into multiple sub-steps, because you, for each sub-step, you can actually tackle each task differently and
Yeah.
use the right tool for the job, which often allow you a little bit more ways of optimizing something. For that, you can do some also cooler, more agentic stuff, which would basically use LLMs, for example, for like decision making, basically control flow. This could be like simple in like agentic RAG, where you have like an LLM model at the end and basically ask it, okay, do I have enough information to
Mm.
answer the user's query? And if not, I basically run a
Yeah.
retrieval again, or I generate a new query and run the retrieval and basically do another loop. And this is something actually that's very interesting to do, that you
Yeah.
can do it like for certain parts in the decision making. We built like a pretty universal web crawler as well. And we use the LLM basically just for deciding, okay, where we need this information, where should we go next? And we
Mm.
basically create a graph of the website, like what are the different pages that exist. And then the LLM basically can decide like where to go next. And the beauty of like using it in like really small subtasks, I can
Right.
evaluate it whether the
Yeah.
output is valid. Because I
Mhm.
have all the paths of the website, I can just cross check whether the path actually exists. If it makes a small mistake, I can basically correct it. I can't just do like the string overlap or Levenstein distance with the original URLs. And if it's like within a margin of 1, I can't just basically assume it's this one. And if not, I basically can decide based on the error, okay, what should I do? Should I try to regenerate or just basically skip it and take a random path?
So two things jump to mind when you were just talking. First is this control flow idea where you have a task that you're trying to solve, and it could be as high level as like, I want to crawl the web for, any input information or something like that. And I guess you have like these different layers of programming the computer essentially. Like level one is you just hard code all the logic, which is, what people did back in the day. Then the second layer is if you have data that gives examples, you can train models like machine learning models to do the logic for you. And then there's like this last level where you can actually have the LLM like performing these subtasks or something like that. So you have like these multiple options when it comes to programming computers. But then it's not just like this control flow of like, okay, if this happens, use this logic. If this happens, pass it to this classifier. If you don't know how to do anything else, just pass it to the LLM because, it's probably the most flexible module in there. But then you also talked about like using LLMs as this decision maker, as like controlling, as basically being the switch. So instead of like using if else or using a text classifier or something like that, you're having the LLM make a pretty high level judgment call, like a yes no decision or something like that.
And you could even break it down again, like
Right.
you could use it more fine grained. And I think what makes this approach interesting, you can do, so how I call it is bubbles. You can basically, for each step, define different options. And this is like one comment we just got from KC. Where is the line for you with traditional code and regex as opposed to depending on LLMs? I think this really goes into this aspect that you can use multiple ways of solving the same problem and see whether they succeed or not, and then escalate upwards in complexity. If I, for example, I want to navigate to a certain website, and in many cases, that's, for example, the imprint, the impressum, I can hard code impressum and imprint and just do a regex match whether this page is available. But many pages don't use the same phrases because it's like it's phrased in some different way. So when I don't find a path that matches that regex pattern, I escalate upwards and take like basically the next option, which would be the LLM or would be something else, and basically try to solve it this way. In like most of the cases, you can solve it with the simple option, which is very computational efficient, but I still have the fallback of the LLM, which is like a very powerful problem solver, but also more expensive than most of the.
Okay, I really like how you're framing this because you can just take like any high level task, or I guess any arbitrary task, you can break it down into different modules. And to keep things simple, you have like 3 layers of tooling that you can use. You could use like traditional software, machine learning, or LLMs. And then you can even like have each module can have different levels of escalation, like you're saying. So for me, like this is like a tricky question sometimes, which is like, where do you start? Because my intuition is start simple. And so from one lens, starting simple means writing just some basic software, some basic if else statements, some code. But sometimes if you want to take that approach for solving pretty complex problems, the logic is going to get crazy and you're going to get thousands of lines of code just to do something simple. But then on the other hand, the LLM is simple from one perspective because it's just a single API call that you have to make. But of course, behind the scenes, you have like this, 1 trillion parameter model from like a computational complexity standpoint is much more complicated than writing some Python code. So I guess the question is like, where do you start when you start, like you create this like wireframe or this sketch of your control flow? Where do you start for like each of these modules?
From a technical perspective or from a problem solving perspective?
Both. Let's talk about both. Let's start with the problem solving. We'll start with like the more practical.
When I'm looking at a problem, especially like I run an agency, so often we have to solve a certain problem, or we are automating away certain parts of labor. The best way for me to figure out a workflow is just looking at what the human equivalent is doing and just basically mirroring them or watching them how they work and what the different steps are. Then you can break down most work humans do into a graph as well. And every time he basically seems to make a decision, you can ask them, okay, why did you make this decision? Because I want to know, okay, when does he branch? When does he go somewhere else? What are like the inputs to his decision, and why is he making it? Because this is something I will basically have to hard code or feed into the LLM so it can make the same decisions.
Mhm.
And through that, you basically try to deconstruct like a certain task into a workflow. When you're starting with something like that, you want to have like a minimum task, like which is as small as possible, but still provides value when you automate it.
Mm.
So usually this is the sweet spot. But by keeping it small, you can build it pretty fast and basically break it down. And also you can even try solve it one shot with an LLM. Then when you solve it one shot, you have a pretty quick demo which shows the user the
Mm.
output, and you can test whether he actually adopts it.
Yeah.
Because that's like another massive hurdle. Like, not just can I solve it, but is it actually valuable to the user and will he
Right.
use it? And once you can actually set like 2 checks marks, like you can solve it with an LLM to like 20 to 30%, and the user actually sees value in it and wants it, then I can actually go to the next step and do the work of actually like starting to code
Right.
and starting to write some software and break down the task into the graph.
Rather than thinking about, oh, do I use traditional, like just some basic logic or an LLM here, the very first step is to like sketch out this control flow or this graph that's representing, all the steps that the human is taking in performing that specific task. And then the more technical perspective of the same question, which is like, how do you make that judgment call of to use an LLM for a specific node in this graph? Or do you write some Python code? Like, is it always that, let me try to do the LLM first because that'll allow me to make a quick and easy demo and it'll have pretty good performance? Or is it like, okay, let me try to use Python code here and not worry about using an LLM?
My default is when I can use code, I will use code.
Okay.
But most problems are fuzzy, that I
Yeah.
don't just need code, but I need like an entire like SaaS product to actually solve it. And you have to make a little bit of a judgment call. How much would I have to code to actually come up with a sensible and decent solution without using something like LLMs? But also, how fuzzy is it?
Yeah.
And by fuzzy, I basically mean it's like, is there a lot of like additional contextual information going
Mm,
into the decision? Is it not
right.
clear what the right result is? Is the input set different every time or slightly different? So I
Yeah.
can't hard code rules into code.
Okay.
And it's more like you have to look at the different tasks and actually judge, okay, can I solve it with software in a
Yeah.
sensible way or not?
So I guess at the end of the day, there's no like hard and fast rule. You just got to use
No.
your best judgment, and I guess that just comes with experience and like building these systems. But
I think
yeah, go
rather
ahead.
common sense in many cases,
Right.
because you can see like when for like 10 different tasks the input is nearly identical, there are clear rules between inputs and outputs. Like,
Yeah.
you can use a rule-based system, and if not, at the moment at least, like LLMs are a pretty good shot that they will work decent enough to actually solve it.
So the second point that you were making is, okay, building is one thing, but seeing if the user actually uses it and it provides value is a different thing. So how do you start making that assessment? Like, how do you, I guess you can put it in front of the user, see if they use it, but like that value generation, like quantifying the impact, quantifying the value, so you can make a decision of like future investment, for example. So I guess there was a lot of questions there, but like, how do you think about that? How do you navigate that?
Where I like to use agents, LLMs, workflows, whatever you want to call it, the most are either tasks which at the moment just aren't done because it would take too much human labor.
Hmm.
And this especially is like a lot of information extraction out of unstructured data. Like,
Yeah.
every organization has like a dump of information, probably valuable information, in different forms of documents. And this extraction can give extreme like insight into the different operations, but it just isn't done because it isn't practical to like let the employees actually go through all the documents and extract the relevant information. And
Mhm.
also, no one wants to do it. And this is like the second hallmark, like, what tasks don't they want to do, but take up a large portion of their time. What I always like to is like in doctor and e-commerce tasks, like doctor tasks are like high value professions, and there it actually makes sense to taking over parts of the work, especially stuff which just takes time and
Yeah.
isn't like their core value driver for the organization.
Mm.
And e-commerce is like just tasks which occur like so frequent that automating them away in aggregate provides a lot of value.
Yeah.
And
Okay.
by this, you can already do like an assessment in advance, like, okay, which tasks are
Hmm.
potential targets. So you actually have like the value already a little bit out of the way. And now the user adoption is the bigger question. And when you take tasks that they don't want to do, it's like the adoption is way easier.
Interesting. Okay, so it's like two axes here. Like one axis is like it's either like the doctor tasks, so it's like really high value, but maybe not so high volume.
Yeah.
And then you have the e-commerce task, which is maybe individually low value, but really high volume. And
Yeah.
then you have this other axis of the user doesn't want to do it. Like it's very
Yeah.
tedious or just like boring, mundane, whatever it is. So I guess the sweet spot would be like either of these like corners, like no one wants to do it. And it's like really high volume or it's really high value.
Yeah. Because if you're coming in and it's like tasks they actually want to do, which is
Yeah.
mostly like their core job, you're always fighting an uphill battle. In most cases, it's not worth it because
Mhm.
even if you build it, it's just not getting adopted.
Right.
Because for me, agents and LLMs are in most cases still at the stage where we actually need human review
Yeah.
for a lot of it. That I at least should let a human check the outputs or use another model which basically flags the confidence or likelihood of the model and use a human to review the like
Right.
unsure examples.
See, we're doing pretty good on time. So we will do Q&A in let's see, like 10 minutes or so. So if you guys have questions, feel free to drop them in the chat, whether you're watching on LinkedIn or YouTube, just keep them coming. So Nico, kind of taking a step back and talking about projects more broadly from like a project management perspective, or maybe putting on like our CEO cap or product manager cap. Like in your experience, why do AI projects typically fail? And what are some of the red flags we can start to look out for early on before kind of making the time and monetary investment in a failed AI project?
A lot of the use cases people come up with are the obvious ones. They often aren't the ones which actually provide value to the company.
Hmm.
And I think like AI should be used to amplify strength over like removing some weakness you have.
Hmm.
And so it's really like, where do your employees spend an exorbitant amount of time, which is really valuable? And can I make it that the employees are better at that or waste less time at tasks which basically just distract them from the core value driver? These often aren't the stuff that people want to use AI in. Often it's a lot of like pet projects which are just driven by one senior executive and he wants something and it's not really informed by any decisions or like by any people who are like doing the actual labor, and so they aren't even asked, but it's like rather pushed downwards. And
Oh, I
it's
see.
like bottom up innovation for me also isn't the way to go. You have to find like a common ground, like
Hmm.
you have to sit together and basically find solutions. And often, like for me, one of the best ways to find good solutions is looking at timetables, like where are employees spending their time? Like what are they doing? What are the
Right.
tasks? Or talking to them in the end, like what are the tasks where you're spending the most time? This is like the business side of it. And then there is like the technical side where you have like so much complexity, because when you're doing an AI project, you have software, you have data, and you have all the AI stuff, and usually like cloud as well. And it's like the technical complexity is immense because
Right.
you have like all the other sub disciplines which exist in like any like IT domain, you have included in AI. And all of them have to work in tandem. Like you need software engineers because you have to integrate it into some form of application. Usually you need like the data parts, because without good data you can't build any AI. Like all AI is downstream from data. you also need like all the cloud infrastructure to deploy it.
Right.
And then usually you also need like a good MLOps practice, because otherwise like the model won't improve. And also you can't handle
Right.
like outages and all the different mistakes that can happen.
Yeah, so there are like three main things that you mentioned. So like one is coming up with use case ideas in like more of a collaborative way. So they're actually providing value. So it's not so unpredictable as like bottom up innovation, and it's not so arbitrary as like top down innovation. And then you're talking about like kind of looking for clues in people's timetables. So where people are spending the most time,
Yeah.
those are some of the areas where you might want to investigate a little deeper. And then I guess the last consideration, which is I feel like is really important, and maybe people don't fully appreciate the investment that's needed, but is like the more technical side and the interdisciplinary set of skills that are required to build an AI system. Because you got
Yeah.
like IT, you got ML, you got data, all these people like working together, and sometimes it's just one guy that's some kind of guru and can do a little bit of everything, kind of like you. But yeah, that's really interesting.
Yeah, and the space also, it's like so fast moving, which
Yeah.
makes it really complex, because you always feel like you're running behind like a steamboat,
Right.
and it's you never can catch up, but you still have to be like a little bit up to date at least.
Yeah.
Which is like why I'm so interested in it, because you're
Mhm.
always learning new stuff. You're
Yeah.
never finished, which you aren't in software engineering. But I think like there aren't so major changes as in AI. In AI,
Right.
it's like at least every 2 or 3 years we have like a completely new paradigm.
Yeah. No, for sure. Like a lot of people who were working in data science for 5 to 10 years when GPT-3 came out or ChatGPT came out, like that's a whole new animal. And, they're kind of just as lost as everyone else until I guess they start reading papers and stuff. But I feel like you hit on a really important challenge these days is that the space is evolving so fast. So, we were talking earlier about like how last year everyone wanted to build a chatbot, and they were so gung ho on like the model and stuff like that. It seems like models are changing so frequently, and technology is changing so frequently. Last year was the chatbot, now it's AI agents. So how do you stay productive and you provide value when things are changing so fast? And basically the line between commercialization and research is like pretty fine and blurred these days.
Stay productive or stay up to date?
I would say stay productive because, staying up to date may not be so important if a lot of the stuff is just noise anyway,
Yeah.
because like most research doesn't, survive. Like most people don't read most research papers.
Yeah.
And really it's like one paper that was published like 10 years ago that has a majority of like citations and the attention. So I guess, yeah, how do you stay productive when things are constantly evolving and constantly changing?
For me, what's really important is like being tech stack independent. Like,
Mm,
I don't care what I'm working with. It's much about like practices and processes. And
mhm.
I think that's why I like MLOps so much, because it's like so much practices and processes. And also search for me is another discipline which I really love and I'm studying like heavily, because it's more about like methods, system, processes to actually get to a good output
Right.
and improve it through like evaluation, error analysis, basically action,
Right.
and basically iterate forwards and make small adjustment over time. And I think this is the important stuff for AI. This is a lot on like data fundamentals, like understanding your data, labeling your data, being really hands-on with all of the data and understanding it to really a degree where you can talk with confidence to like subject matter experts about it. Then it's the processes come into like training, like continuous retraining. When do you
Yeah.
trigger a new training run? How do you actually detect that a model isn't working perfectly anymore? And
Right.
there is like a lot of process around that. Like it's not just quantitative metrics which will tell you that, but also like user feedback and stuff. This is something that's really hard to learn,
Yeah.
because it's locked in like behind company doors
Right.
and in the hats of people. But
Yeah.
this is something you usually just pick up through experience and years of just being in a subdiscipline of AI. Like,
Mhm.
how do you approach a problem? How do you actually take a training data set, clean it up, and get a good model out of it.
Yeah.
And then if you got that down, it doesn't really matter what model you're using,
Right.
because usually you have inputs and outputs in your training data, and you have a model you're training. And training AI has become very easy, especially in
Yeah.
the last 2 years. Then taking it into production is more about like the processes and practices around actually monitoring the model, and when
Yeah.
to actually notice, okay, I have to do some updates.
Yeah, so it's not, don't get so caught up with like the latest and greatest tools and models and things like that. It's really about like these like foundational or like key processes and practices, like you said, that they're like the technology agnostic aspect of the field, or just like implementing these technologies. I like that you're talking about like iteration and continual learning and just improving the system over time. So it's like, when you ship it, it's like you've almost like just begun, because like now
Yeah.
you have to fine tune it through continual usage and user feedback. We've started to get some questions in the chat, so let's take a brief aside to do Q&A, and then if we have more time, we'll come back to my questions. But I want to prioritize the Q&A questions, make sure we have time for that. So we got to KC's question already, which was where's the line for you with traditional code, regex, as opposed to depending on LLMs? I feel like we touched on this, but did you have any other thoughts on when to use just traditional code or depending on LLMs?
So it really depends on the stage of the project again, but in the end, use the simplest tool for the job that you actually can do, and simple in terms of how fast can I implement it, how well do I understand it, and how much does it cost when I actually use it at scale.
Okay, this is another one. Going back to our first question of the discussion, isn't an AI agent just an LLM in a loop?
I think we answered that in the beginning. I think like how the term is used at the moment, an AI agent can be nearly everything. So for me, I like to call it like how I use them, or like what I would like also classify as agents. It's like, for me, it's workflows in the end,
Yeah.
which I'm implementing, where I'm using an LLM in a loop, or like for making decisions, like in a control flow, like for if and else conditions. And yeah, in the end, it's like an LLM in a loop, or in a multi-turn conversation.
Yeah, I like that. So the answer is yes. And if you were to ask, is it just a control flow system? The answer would also be yes. So if you keep the questions, okay, do you also train your LLM small to that task?
I think
Also,
he means
oh, I
like the
see.
subtask which we are solving, in like
Yeah,
while
okay.
we are decomposing the task into multiple steps. I want to say yes, but in many cases, no. Nowadays, it's very easy at scale to use something like OpenAI, because you can send so many requests to it. And if you have a workflow that is actually like executed often, it's immensely complicated to actually deploy multiple small LLMs fine-tuned on the different subtasks, and you also require much data. Like the dream workflow is usually you decompose it, you use something like OpenAI in the beginning for the different steps, you collect training data over time, you label the training data, so you do a manual review of it, whether it was correct or not, and then you basically use it to distill the knowledge into a smaller LLM, which could be a fine tune of like a GPT-4 mini as well, or a custom model. But using only custom models and multiple of them is like a big burden for the organization in the end, because you need a few people who are only responsible of
Yeah.
managing the entire infrastructure, which is also like probably a bigger cost than using OpenAI at scale.
Right. Yeah, I like that. Just to linger on that question a little more, it's like this longer term investment. Like in the short term, if it's just like this short term thing, then make the API calls. It's going to cost you basically
Yeah.
nothing. But if this is going to be something you see your organization using for the next 10 years, then okay, now maybe it makes sense to fine tune these models so you have the ML ops team in house that's maintaining everything.
Yeah, but for like especially like AI MLOps stuff, if you're building out a new team, it's often very valuable to start with like only one model, and just like we really sharpen the blade,
Yep.
have it running smoothly, and then add more over time. But if you just expect like a few models in production, you don't really need like the like complete MLOps organization. I would then basically
Right.
still opt for like either a managed provider or something like OpenAI. So
Mm.
this, by the way, I count as well like into like the like managed options. I could fine tune a model and just use something like Together, which
Right.
is also like the managed option,
Yeah,
but
yeah, yeah.
then you don't really have such a large like pay difference to OpenAI
Right.
usually.
So it's like on a spectrum. Like you don't have to just immediately start sprinting and scaling up your ML function. You
Yeah.
can kind of there are steps to kind of slowly grow that at a company. Sundar asked, "How do you see AI agents affecting roles like UX UI? Do you see companies hiring less for this role since it's making designers uh, more efficient and therefore don't need as many?"
It's so far out of my domain. It's really hard to answer. I have like honest to God, I have no clue about UI, UX, and like the hiring patterns and stuff like that, which is happening at the moment. I think if
Mm,
it's similar to software engineering, where all people assume, okay, software engineering is that, and at the moment hiring is down, I would say no, with a caveat. I think like a lot of junior positions might get like redundant because with an LLM, like a senior programmer or a senior developer is just more efficient. But at the same time, since most organizations have a lack of developers, usually you still hire the same amount and train them up. It's an investment in the end in the future of your organization and in the software developers. And for UI UX design, I think you have like a lot of like citizen design which might be going away. Like I can now generate logos, yes, but in the end, like I for like for my podcast, for example, I still use the designer because
mm,
the generations just like weren't good enough. And often you
yeah.
need like a subject matter expert to actually bring ideas, bring his perspective and his experience. And when we see AI agents, like a lot of people like think we want knowledge, but usually we want experience.
Mm,
And I think like humans still have the edge, especially like more senior people in experience, and they
right.
will keep it.
Yeah, so it's like taste, you're going to hire a designer, specifically a designer, because they have, whatever palette, they know what people
Yeah.
like, what looks good. I guess a follow-up question to this for you, Nico, you're building a UI or you need to build a UI for your product right now. Are you going to be just using like an AI assistant or like a tool like V0, or are you going to hire a designer to help you with the interface?
So it's like I'm coding an application.
Hmm.
So like my interface is mostly grayscale, and I have a little bit of design jobs that I know like okay, I like to keep white space. I like to order it well, but when it gets like to color schemes and stuff like that, I would hire like a designer or a front end engineer, something like that.
Okay.
Um, but like the application stuff, I'm doing it.
So you're still gonna hire a designer for your
Yeah.
front end? Oh, okay.
Yeah, we also still have a really ugly logo.
Okay. So let's see. Casey asks, at what point will agents become reliable? Like, is it structured input output 2.0 or better, or is it simply a category that will, should, forever be aside from standard code?
I think agents as like taking multi-chat agents or like the multi-turn stuff, I think we will have a hard time getting them reliable. And I think it's like near impossible without like huge jumps in performance or something like really expensive reasoning models. And then we are at a state where like most tasks aren't worth solving when I have to pay like O1 for each single step. So I think like these agents, they will become better. I think like reliable in the term of like how I use it, like in a B2B setting, like 90+% task completion rate. I don't see it happening anytime soon. So I'm much more interested in actually doing workflows, which basically mirror what a human would do in the agent's place and basically breaking it down, decomposing it, and using LLMs at points where they're actually well suited for.
Right.
And I think like if you use that as like agents as well, I think you can go really far.
I like how you frame it and think about it as like this graph essentially of like multiple components working together, and you pick the tool for that specific module. We got one more from Brian. Where's the line where you steer public versus private LLM? Maybe like how do you decide between using an API or hosting it yourself?
So in the beginning, I'm always using public or like closed source LLMs because I'm just faster. In the beginning, I want to focus on like what is the problem, breaking down the problem, does it provide value, like the whole product market fit discussion as well. When I got that down, like I solved the problem, I can solve it already to a high degree of accuracy. But now I really need like it's the next step. I need to scale it up and
Yeah.
like make it better the next order of magnitude, like from 90 to 99%. Then I actually have to tackle like each component I have and really optimize the shit out of it. And for that, like open source models can be a great tool.
Yeah.
But the same holds for like not using open source models, but trying to encode it in like heuristics. Or I might just use a classifier instead of an LLM.
Just random question. Do you have experience with the llama models, like specifically llama 1B? I feel like I get excited about that because I feel like that's small enough where I can run it on my machine locally and do a lot of experiments and try a lot of things. But it's like big enough to be powerful. Do you have any experience or I don't know, any intuition or musings around like models like that?
So I'm mostly using the small LLM class from Hugging Face
Oh,
because like
okay.
Llama is a little bit tricky in Europe.
Okay. Oh, okay.
So it's like I've used it, I fine-tuned it for like personal use cases, but professionally in the end, I can't use it. I'm a big fan of the small family of models, and you can use it for many different applications. I think like for higher order reasoning tasks, and for that I also count like writing coding and stuff like that. You like these models won't be sufficient, but for really specific tasks. So I use it, for example, like every single document which I'm downloading is basically tasked and tagged and renamed. For that, like small models like that are just like perfect magic. You can fine tune
Okay.
them on the tasks and basically just execute one function.
You said a small language model class on Hugging Face. Are these models developed by Hugging Face, or yeah, I'm not
They
familiar with
have
these.
trained them, yeah.
Oh,
Small
okay, cool.
LLM, SMOL.
Okay, so I gotta check those out. I didn't know about that. See, that's what I love about AI machine learning right now. It's like a hacker's paradise. You know, it all
Yeah.
started with BERT and GPT, like right when you like got into it, because you know you have these models and you can just hack them, fine tune them, do fun, interesting things to them, and you don't have to worry about aggregating a bunch of massive data sets. Like, still, you got to get some data together if you want to fine tune a classifier or something, but you don't have to get like hundreds of thousands of examples or something like that. So keep the questions coming if you got them. I guess we got like a few more minutes here. We talked about like at a high level when projects fail and like some clues to look out for to like, you know, building these agentic AI systems that actually provide value, and then like how to approach and like think about engineering them. But like as far as like specific examples, like what have you seen or like what are you seeing that are specific use cases that you feel are very promising or have already generated a lot of value for clients?
By the way, which surprised me, what the like biggest investor or spender in generative AI apparently are banks. So I'm at the moment looking heavily at like fintech and finance workflows.
Okay.
And I think where I really like LLMs is like information extraction. And I wouldn't call it agents, but I think like LLMs or like if you need multiple steps, it would count as an agent at like the current definition. So it's like information extraction is for me like one of the prime use case, and also like in a business context is something you actually like need a lot. Also, if you think about like a lot of like filing data entry tasks and stuff like that is really interesting, and there comes a lot. I think we have seen a lot of like call center stuff already, but I think like more the miscellaneous work in a call center, like for example routing calls routing customer requests or doing triaging, like basically deciding how urgent it is. It's actually really interesting to use, like, for example, also like a more agentic system, which has multiple components, because it could run a retrieval on basically a certain issue that comes in, see whether it has faced similars already, and then basically classify it into the same class and finished. And there are like a lot of different use cases. It's like more about like being creative and finding one which actually provides enough value. And I think like then it's more about like what you try to solve, like the problem you're tackling, than how you solve it. Whether it's a true agent by like the reinforcement learning definition, by like the marketing definition we are having nowadays, it doesn't really matter. I would rather focus on like problem spaces and figuring out a good problem in an industry you know well, and then basically figuring out a solution for it. I only would say like LLMs and like the whole agentic stuff has opened up a lot more areas which were infeasible before, which require like a little bit of reasoning and thinking about documents and unstructured data.
I can imagine the call center use case and like the call routing, and you have like this massive web of like, you basically have like a control flow for like how call routing could go, and you can start incorporating the different software systems into that. But I'm trying to like have a picture in my head about like what the data extraction might look like. Is this just like for single documents, or are you talking about like a wide range, like maybe thousands of documents or something like that? Or are you not even talking about documents? You're talking about like all sort like web pages and tables and Excel files. Do you have a specific example of like that data extraction use case, maybe like for banks or some other industry?
Yeah. So in the end, anything. It's like most of the stuff is unstructured data. It's like HTML masks as like semi-structured, structured data, but in truth, if you actually go on a website and you download the HTML, for you it's unstructured in the end, because you don't know where the information is, unless you know, like I'm scraping this one website and then I basically can't just figure out the CSS text. So I think like from web pages, like getting information from out of there. One interesting use case I've seen recently, which I want to replicate, is basically getting all the water quality information. One guy did it in the US from all the different cities, and basically just made it queryable, like created a front end, made it queryable, because before that it was only available on like the different city homepages or even in like PDFs. And he basically just extracted all the different information and made it available and built like, I think he monetized it with like affiliates. So basically advertised some water stuff on top of there.
Yeah, nice.
And I think you can replicate this in a lot of different areas. Like, what information do people actually want to access? Then just try to aggregate it. And like with LLMs, you have the capabilities now. And when we are moving into like more of the financial space, I think like if you look at, I worked in accounting before, and like very early days in my career. And it's in accounting, a lot of the work is actually just like getting proof for certain financial information the company basically tells you. And this is often like written documents, but also like some PDF, which is not well structured. And your job is basically taking that information and just copy pasting it into Excel sheets. And I think like this is also like a task which can be automated by a lot. Anything that's like human world stuff, where you have like handwritten stuff, for example, or documents which are scanned in, now with like vision language models, stuff like that becomes way more feasible than it was before.
I really like the example you gave of that water quality thing and the guy setting up the API, or I guess the way to just query that data. It just kind of like blew my mind, because it's like there's so much data out there that people need, but before, like, the bar was just too high. Like, it was just such a massive effort that it didn't make sense from a like economics perspective. Like, you would invest all this time and you probably wouldn't be able to make much money on it. You invest like, I don't know, like 2 years building this API, and then you make like $1,000 a month from it or something like that. It doesn't make sense. But like now the barrier to entry is so much lower that, maybe that guy, instead of him taking him like 2 years to make this thing, it took him 2 months, and then he's making like recurring revenue on the advertising. Like, it just makes a lot more sense from a business perspective.
There's like a lot of data which could be information and used for like decision making.
Yeah.
And it's like there are so many like niches, subpopulations,
Right.
which are interested in certain pieces of information. That it can be just interesting to basically aggregate it. I think like another major trend at the moment is microplastics, which is something I just like thought about doing as well,
Okay.
because most of that information has to be like written down somewhere
Right.
by law. And you
Mm.
could also like look at all like water bottles which contain microplastics and then put it on a website and just basically what's the best bottle for your health, for example. And I think there are like a lot of different cases like that
Yeah.
where it's just like informing consumers or informing different like job groups on different things is getting feasible. And I think like most of these to date were like sites like, for example, like Zillow, or I think there is one
Right.
HR one where you basically self-reported your wages and then you get access to the other people wages as well, where
Right.
people had to enter their own information. And now you can actually like skip that step and actually like use the unstructured data which is out on the internet.
My mind is like running with these super niche like data scraping and aggregation like business opportunities. I got to do some of those in 2025.
And these are really fun, like because like
Yeah.
once you've written a few like information
Right.
extraction pipeline, it's like
Yeah.
it doesn't change so much.
Right.
The only thing is like how do you actually find the data, which is mostly like most of the work you have to figure out, and then basically you automate like the gathering of the different sites.
I feel like the biggest challenge is like nailing down a niche because I feel like there's like
Yeah.
countless niches, but then it has to be something you know a little bit about. I mean, there has to be like a customer that it's providing value to them. So I guess it's more in that discovery phase, and maybe that you'll build out a agentic system that'll go out and do research and come back with like I don't know like 10 feasible startup ideas or something like that. Okay, we got another question from KC. Do you write your own agents or do you use a library? Also, have you used Pydantic AI agents yet?
I haven't used Pydantic AI agents yet so far because like when you're building workflows, it's like a lot of business logic which is actually written on top of like the LLM logic. And I think like most frameworks are really unsuited for that. And as I said, like stuff like these multi-agents, I don't like them because I think debugging them and doing a performance analysis is very hard. Like I have four different like personas, four different agents who are chatting with each other, and it fails. Like where did that failure even start? Like can you trace it back? Probably not. And even though like if you could in theory, like you would have to read through like a mountain of text to find one error. At the same time, like when I add an agent, will it like become better or worse? I can't really predict it. And when I have like more fixed components, like I have a classifier, for example, which is a part of a workflow, I can see the accuracy of this classifier on its own. Whereas in a multi-agent chat, I don't really have a fixed workflow. I don't know what's going next. So it's always path dependent, and the path is completely flexible. It's completely free. So I can never predict it. So also like the performance analysis is like always different because the input is always different. So I can't really optimize it. And when it comes to something like LangChain, for me, it's LangChain is a tool for prototyping, which I have to get rid of once I progress more.
Mm.
And it's like the time I save using LangChain is not big enough for me having to throw it away down the road, because often if you have to remove a library, it's a major refactor.
Mm.
And I don't really like using stuff like that which have like a really low ceiling of how far I can customize and push it. And usually when I have to like solve a problem, I have like a lot of business logic and customization in there.
So you'll like default to just building the modules from scratch at the gym.
Yeah.
All right. Well, thank you everyone for the great questions and joining us live. Nico, thank you so much for sharing your insights and expertise. Like I said, like I always learn so much from chatting with you. So Nico, thanks again. Everyone, thanks for joining, and we'll see you next year. Take care.